Anyway, I'm really glad to be here. In fact, it's a long time since I've been at a workshop where every talk and every person I've talked to has obviously been thinking and doing work in exactly what I'm interested in right now. So this has been wonderful for me. I'm at Carleton University in Ottawa at the moment. One thing that people are often alarmed about when they talk to me is I have an accent that wavers all over the place. I was actually born in the UK, moved to Canada, and spent most of my adult life in New Zealand, where I met William and know Craig very well, and then moved back to Canada. So my accent tends to be sort of mid-oceanic, and I will often pronounce words differently, even if they occur twice in the same sentence. This work is about security analysis work. I sometimes call this area the I word, and I'll let you think about what the I word is. But our focus is on collaboration. And really, all I'm going to do is talk about 6 pieces of work that we've been doing in the recent years. So, as you all know, when a professor talks about their work, it really means the work of a whole bunch of other people for whom they're taking credit. I put all of my references on one slide, and this is the work principally of my postdoctoral fellow Judith Brown at the top left, and long-term master's student Jeff Wilson, also at the top, and some recent students, Peter Simony, Ravina Samaru, and Miran Mirza. And I'll talk about their work as we go on. Our background is a solid mix of human-computer interaction and software engineering interpreted broadly. We're particularly influenced by activity theory, particularly in the what's used to be called as the Soviet school of psychology, the world of Vygotsky. We used to have a Vygotsky fan club. Our students were so keen. And more recently, the work on distributed cognition by Ed Hudgens and other people's group at the University of California, San Diego. In fact, we see distributed cognition as the contemporary avatar of activity theory. We did a lot of work on understanding collaboration in software development teams, particularly with agile programming, Kent Beck's book there. And we also do work on information visualization. We're particularly influenced by the human factors approach of Colin Ware. And our really big emphasis on application area for the past decade has really been human factors in computer security, the area that's often called usable security, pioneered by this book, edited by Laurie Craner and Simpson Garfinkel. And that's brought us into visualization for computer security, exemplified by this book by Greg Conti. So this is kind of our world. And when we started our work on usable security, we were principally focusing on the end user. We've done an enormous amount of work on password systems, anti-malware systems, and the psychological underpinnings that are leveraged by attackers. But then we decided to focus on the people behind the scenes. And this led us to what I'm calling the Zeroth study, which was a big overview of surface computing and collaborative analysis work. And we're here focusing on so-called security information workers, but this was background. We were one of the many groups around the world who built our own touch tables and large touch screens back in the early days. The one at the top there shows my students studying collaboration with a game with hardware entirely built by us from parts from hardware stores and junkyards. This is our more recent approach, using slightly more commercial equipment and working with children. So we reviewed the whole sort of area. And basically, the thing that drove us is that large touchscreens, which we expected to be a much bigger deal than they've recently turned out, were the ideal technology to support collaboration, and in particularly collaboration for thinking. And so we started our formal studies after that. And our initial study that I want to talk about briefly involved security operations centers This isn't one. We didn't take any photos of the real centers. This is just one from a newspaper. We studied 6 sites, or 7 depending on how you count them. Our approach is principally ethnographic. We do interviews, but we do a lot of observations. We do a lot of camping out. In each of those studies, we were there for several days. We spent whole days and hours, sometimes day and night, studying the workers. We did a variety of sites, some financial, some military, some governmental, and in both Canada and the US. And essentially what we were trying to find out is how teams work. Was there a model that worked all across centers, and were there implications for tool design? And our findings in there's a paper I gave the reference for earlier, is that increasingly people are moving away from things influenced by the so-called ITIL model, often known as the tier-based model for response, tier 1 being help desk, tier 2 having more technical expertise, and so on. And we call the model that we now have these tailor-made teams, where people, on the fly, on the basis of known expertise, assemble teams for particular practices. And yet, everyone on these teams is doing multitasking, so they exist in a kind of ad hoc matrix management world, where they will be collaborating in one day with as many as 10 different teams, all of which are composed with a mix of skills and people. And while we saw this working, we really saw a need for better coordination, for better decision making, and those sound high blown, helping decision making. That sounds like a profound thing. I think we're all interested in this. But we also found some value in lower level things. For instance, they spent a surprising amount of their day having to document what they did. And they hated it, hated it, hated it. I mean, it was like these police programs where you see that, at the end of every heroic day ends with having to compile incredibly boring bureaucratic paperwork. What we saw was just like that. And they hated it, they did it poorly, and we thought they really needed a lot of support in that. And one thing that we made fun of, and they made fun of, we later realized was also quite important, which was customer relationships. They typically work in rooms that do look like this. And when we asked them about this, especially the big screens at the front and everything, they all joked that it was entirely for public relations. And we even went to some where they had a special viewing gallery so that the managers could bring in important visitors and show them what was going on. On the first one, we studied, people refer to it as the Star Trek set, or the Starship Enterprise sort of set. And we kind of joined with them in making fun of that. We wished it would work better, but here was our important realization from this, and this happened across these centers. That was in fact really important, because if they didn't have the buy-in from those high-level visitors and customers, then they lost a lot of ability to really work with them, to get their business, and to get their trust. So we ended up being a little less cynical about it as time went on. So that was our first study. And from then on, we decided to focus a little bit more, because some of these are dealing with things that we're less interested in. When I say some of these, I mean some of the centers and some of the people. Sometimes they're focused on network issues. Sometimes they're focused on trivial issues. We were particularly interested in security operations. And so our next study went to the other end. And we studied intelligence analysts. We studied a team of 10 professional intelligence analysts. We ran a study over 3 days in 2014. We were doing this at an unclassified location. One of the things that anybody who's done work in this area will know, getting access to these sites, whether it's government or industry, is tremendously difficult. One particular site took us 2 years of delicate negotiations to be able to do the ethnographic study. One of the ways that we were able to do this is that we did it in an unclassified location. And we did a study of unclassified work. In fact, what we did the study of was the Enron data set. Now, Enron, as you may recall, was the American but globally operating energy company, which collapsed a number of years ago for various issues having to deal with corruption. And as a result of the investigation, the entire data set of their emails and documents was made public. So this is a kind of a nice real-world data set to do lots of analysis. And intelligence analysts, and our research questions were, what were their work practices? How did collaborative work turn out? And what were they collaborative artifacts? Our focus on artifacts comes very much from our emphasis on Vygotsky. If you know the history here, you know that Vygotsky says humans address objects using tools. Vygotsky didn't particularly mean physical tools. He often meant conceptual tools as well. So we're looking for those tools, those artifacts. Here's what we found. Probably the biggest surprise to us was that the center of their process involved what they called the bowl of knowledge. Kind of oddly, but perhaps in response to the question earlier on about sense hyphen making versus sense making, is that they were cautious not to seek a coherent story where they didn't think it was clear. They had this model of sort of a bowl of fruit, or a smorgasbord, or a buffet, if you want. Obviously, they would knit things together where they thought they really did, but they did not feel obliged to do that. This turned out to be an important thing. What did we see? We saw lots of collaboration and collaborative artifacts early. They did brainstorming, they had post-it notes, they split things up, they did affinity diagrams, all of the things like that. And the two things went together. Where they collaborated, they typically had artifacts. Where they had artifacts, they typically collaborated. But we drew this little diagram here. We're using a model here by Yrjö Engström in Finland about kinds of collaboration, going from less collaborative, which we kind of euphemistically call side-by-side coordinated, which means they're working on related things, but they're doing so side-by-side, versus reflective communication, which Engström regards as the highest, most powerful form of collaboration. And we did this kind of plot over time. And you see a lot of oscillation in this. But you'll notice that what happened later in the phase, where the real sense-making is going on, essentially there was independent work alternating with what we called cooperating work. And that had one particular character, which was people asking for help with technology. So that when they bumped into a sort of a problem with one of the tools they needed, they would work with someone else to solve their problem, but there was very little that went beyond that to reflection. And so we thought that this pattern of the full range here and a much more limited range, and in fact this alternation here, was really quite interesting and showed something we wanted to know more about. There was an exception. One of the people produced a map, or actually a set of maps that you see there, and everybody crowded around and looked at it and giving comments. It was hard to get away from the feeling that this happened just because it was big. Because I have this big thing, everybody comes and looks at it. Very, very curious. The incidence of someone walking around and saying, hey, what's that cool thing on your screen? Almost never happened. Big picture, so big that you can't ignore it, and he feels it's okay to come look at it. We thought that was cool. The thing that really stood out to us, especially because of our earlier ethnographic work on software development, particularly agile software development, is this. There was no collaboration with the customer. Absolutely none. It was forbidden. when we asked about this kind of thing, that was not just defended, that was asserted as a principle. They thought it was important to not collaborate with the customer. And we can talk about that later if you like, but especially coming from agile software development, where there was a lot of collaboration, we thought that was easy. Yeah?
In this instance, who was the customer?
In this instance, the customer was represented by another person who was part of our study, who was acting in the role of the kind of customer they would have in real life. Okay? You'll notice me being relatively cautious about describing who these people are. Yeah. The answer is sort of one and sort of the other, mostly because the groups they all work for the same organization, okay? But even this place runs a kind of a matrix management sort of thing, so it's not always clear to say whether they're part of the same group. I think that's actually reflective of the real world, because that's the way they actually work. So it's not really taking it one thing we did find out, one thing we observed, is that we saw a couple of people using this thing called ACH, Analysis of Competing Hypotheses. And this is an example of what the intelligence community called structured analytic techniques. And we were fascinated with this because it had potential. So this person was using a spreadsheet. I believe this is the actual spreadsheet, where you put evidence in a column and you rate its credibility and its relevance, and then you test it against various hypotheses. I really wish that when we initially took the artifacts from this, I'd chosen something less miserable than is it suicide or is it murder, which tends to make this kind of more shocking than it need be. It turns out in the Enron investigation, one of the chief financial officers, a chap called Baxter, was found dead in his car one day, the day before he was due to testify at an important hearing. The question was he really the case of suicide? Nobody really knows the right answer to the criminal investigation, which came to an answer, but this is regarded as one of the unsolved issues. And so the analysts in this case are using this to evaluate what's suicide or was it murder. I found this fascinating and replicated it myself and actually came to an answer myself using this technique, which I can talk about if you want, but then again, I wasn't involved in the study, so I wasn't trying to study myself. We thought this was really cool, and we thought this has potential. This turns out to be something articulated by Dick Hoyer here, Richard Hoyer, who had a career at the CIA. In this book, which I recommend, this little book, written principally by Hoyer, goes through a number of the techniques. A lot of them are things we know well, such as brainstorming, card walls, and role play, and things like this. This particular thing is a little bit more advanced because it makes a mathematical model. It has you assess the evidence as regards to both credibility and relevance, and then consistency with a set of hypotheses. Now, Hoyer's suggestion for this is principally that it helps analysts avoid cognitive bias. You walk through these kinds of steps. It's got a kind of a hands-off, step-by-step feel, because when you assess the credibility and the relevance, you're not doing the hypothesis. When you do the hypothesis in the next step, you're acting independently, and then the model spits out an answer. So you haven't really been able to drive it, and this is one of the ideas. And like this, these days, for a slightly different reason than Hoyer says, And I think because of Kahneman's work here, particularly in his recent writing, a book a few years ago, Thinking Fast and Slow, summarizing the work that he did with Amos Tversky, now sadly dead, means that I think we've got to be very cautious about this word cognitive bias. As William said, we might all be thought of as having bias, but Kahneman's line now, right, is that we've got these two different systems that we're operating that Kahneman, very offhandedly calls System 1 and System 2. And essentially, Kahneman's line is that our cognitive systems has all kinds of shortcuts, System 1, that we use for efficiency's sake for problems that it seems like we're really very familiar with. And therefore, I would kind of regard tools like this as basically helping us make certain we don't take those cognitive shortcuts where we shouldn't be. But also the thing that I see underpinning this model is that it has an emphasis on falsification. And this comes back to the work of Karl Popper here, famous philosopher of science, in his work done principally in the 1950s and 60s, where he says that in doing scientific work, you'll gain best when you have a theory if you try to falsify it, if you try to find evidence which contradicts what you think is going on. Because that way, you're being honest with yourself and you're really testing the model as best you can. This is something that I really like, principally because it takes us away from something which I think is really very common in our software world, which is, I had this cool idea for this product, here it is, I tested it, it seems to work. Big win. We owe it to ourselves, if we're being honest, to really try and find ways to make it better. Now, it's always as simple as it could be, and I've made this mistake several times in my career, where you instantly see that there's casework fails and so you abandon it. And I've learned that that's wrong, because in fact, you can just fence that off and say, well, it doesn't work in situations like this, but it might have huge value at other times. But I see this as a way of keeping yourself honest in this analysis. So this was our finding from this big study. Let's just back walk through. They collaborated early, but not late. They didn't collaborate with their customer, hardly at all. And the exception one, when there was something around a large image. But they did sometimes use this specialized tool by charting things on a spreadsheet, and it seemed to have a lot going for it. So this led to our next study, where obviously we built a tool. We call it ACH Walkthrough, and it combines a number of things. First of all, it's based on the studies. Secondly, it uses large surface computing, so large touch screens, which our lab is littered with there. We're using information visualization, and we're using distributed interaction. And you see me playing with it there with my student Jeff Wilson in the background, who built this system. Now, there has been software for ACH before. The original one, developed in collaboration with Hoyer, was at Park. There's an open source one by Burton, and there's a commercial one by Global Input. They're all essentially desktop tools that work in a spreadsheet-like manner. That turns out to be more important than I realized. But we wanted something big, and we wanted something that people would crowd around and collaborate with. So here it is. This might seem boring. Well, it is boring. The home tab does that. Off this tab, you can make stuff up. But the important idea here is that we were trying to leverage what we see in software. You sort of made up a project that kept everything together. That turned out to be less than totally trivial, because that's not what they had so far. They were just keeping things together roughly in folders of Excel files. When assessing evidence and credibility, we made these little things. This was one example of kind of graphical formalism that we were keen on at the time that we called a fretboard. And the idea here is that you assess credibility and relevance from low to high here by moving this dot around this screen. What's important about this, frankly, is that it's big and visible. So when someone did this on a wall up there, everybody could see it without even trying. People would get into little arguments about whether that dot should be a little bit higher or a little bit lower. The funny thing was we had it granularized at first to just low, medium, and high. But we found everyone wanted to say, no, we see it lower for that one than the other one. And so we had to change the design on that one. I think that's an intermediate one. That was a little bit odd. But this helped in the same way that that big map did. Because it's big and because it was so visible, people interacted. The consistency tab here worked the same way. We have a sort of another little fretboard here influenced by Hoyer's original design that basically allows the manipulation of the different hypotheses. The 0 and the 1 there are hypotheses. And you see the various pieces of evidence being rated there. There's the death report from the coroner, there was a gunshot wound, there was a suicide note, there was an autopsy report, and there was something to do with the hands of the corpse. Gosh, this sounds gruesome. I wish I'd chosen something nicer. I liked the one the other day about theft from the art gallery. That seemed like relatively clean and also and this had the same effect as the fretboards we showed earlier. Because it was big, people engaged and discussed around this. This comes back to the discourse idea that William, I think, you referred to as well. Although something weird started to happen there that I'll come back to later. What we were most excited about was this, what we call the graph tab. This is, of course, Inselberg's parallel coordinates display, again, which we're pretty keen on, where we related all the evidence items down the left with their credibility, their relevance, and their hypothesis, so that you can see the paths going across there. The remarks made by Alex the other day about the limitations of parallel coordinates here come into this. Notice in this, we're using a variant where we basically kind of curve through the points, which makes it a bit easier to follow them. We also make it possible to highlight one by clicking on it where it's more distinct and then following it through. And perhaps more importantly, we have a lot of interaction where we can brush on this to isolate ones that we're interested in, and we can also change the order of the axes, which allows us to make a cleaner sort of model. Basically, I think those are all really very important for parallel coordinates. And I still like parallel coordinates, but I'm a less of a kind of zealot about them than I used to be. The main thing that I liked about them when we studied the effectiveness of this thing, again, is that it caused people to see the data in a new way altogether. And they would poke at it together. So we have a lot of, why is the resignation letter represented as more credible than something else? Why does that pattern exist? And these are all of the kinds of things that we want to see if we're encouraging discourse. The other thing that we did in this is a walkthrough process. We're leveraging here the work of Clayton Lewis, University of Colorado, many years ago on cognitive walkthroughs, where we have a little process. There's a kind of a strip across the bottom that basically gives you a little guidance about what to do next and what to think. This comes from our observation in the earlier study, later corroborated by other people, that people just are not familiar with how to apply the process. So we took the sort of HCI viewpoint of building the guidebook into the product, so you sort of walk through it to remind you. I'm not entirely certain how successful that was, but it did communication, and it also, to a certain extent, encouraged role play, which is another structured analytic technique, where one person would take the position of devil's advocate, one person would take the role of defender, and this reminded you to do this. I'll talk about the architecture later, and our walkthrough steps are based on the advice of player. We didn't make them up, so we're basically just turning player's device integrated into the tool. Okay, so let's talk about the technology. Because we're techie people, and I think we do it. So we're using SVG on the web. We've used SVG for a number of years. I think our first project on this is now 14 years ago, which seems an age. But we're particularly keen, or have been recently, on the U3 framework by Mike Bostock, which was part of his work at Stanford. The reason that we really like it is the way that it makes all of the data react with each other. And this connects with an idea that I always loved by Steve Hanoto at the University of Washington, the default liveness. But more recently, and basically following Colin Ware, I like to call it epistemic interaction, which is to say, it's fostering the manipulation of the data not to perform a task, but in order to think about the data. In other words, we manipulate it with no particular idea of what it will look like, or why we should look at it that way, but just to try things out as a way of getting new ideas ourselves. I don't have another slide about it, although I should. I should come back here to a running argument in our lab. Everybody likes this. Everybody loves this. Everybody loves to touch the data and see all the reactive things change at the same time. One thing that we realize is that in a way, this goes completely against players' motivation of limiting cognitive bias. If you can change any of the underpinnings, then there is the possibility that you will change things where you have power to make them suit your bias. You know, the great advantage of spreadsheets when they came in is that they supported this kind of what-if loop. When you're trying to do your budget and you look at your rent and your other bills and you see that you can't pay them, you can decide what you should reduce. You can play with things until you get the answer that fits. But the problem is, you'll get an answer, sometimes doing things which don't reflect reality very well. And we're concerned that in security analysis, this might be a backdoor whereby people can generate from data the answers that they have a hunch about anyway. And I see this as potentially problematic. The other thing that we played with here, which we loved at the time, is a synchronization tool called Meteor. And this was a big startup in the Silicon Valley area a few years ago. And the idea here is that it's a follow-on from Ajax and Comet. So Ajax, of course, was asynchronous JavaScript in XML. This was the thing that allowed web pages to go back to the server on the fly, rather than you having to replace one whole page with another whole page. Generally regarded as, you know, the underpinning of Web 2.0 and flagship things like Google Maps and various other things, which were running almost like applications in the browser. There was a less heralded system called Comet. Well, system, identity system is a way of doing things. Comet goes the other way around. Comet is a way for servers to update web pages on the fly without any interaction. You might ask why it's called Comet, and that's because in North America there's a bathroom cleaner called Ajax, and its closest competitor is called Comet. This is total geek humor. And by now we're on a kind of an astronomical sort of thing, so having had Comet, we now have to have Meteor. You can't make this stuff up. Anyway, what happens with Meteor is that there's a local data model which is invisibly and constantly kept in sync with the server data model without the programmer having to do any work. And we liked this model for a couple of reasons. One is it totally trivialized the database handling on the client side. But the other cool thing about it is that it means that several people can have the session open at the same time with the same data. So you see here, my students working on the large touch screen, on a tablet, and on a laptop. And the interaction that's done in one is immediately reflected in the interaction on the other. And one reason we particularly like this is that you didn't have to be in front of the big board. When you're doing more complicated data entry, you could do it in your laptop. If you were a long way from the screen, you could point at things and you could update them from your tablet. And we have a weird add-on whereby if you hold your finger down, it makes a kind of a laser pointer on the screen. It looks like a laser pointer, but it's just a red sparkly thing that anybody can sort of control. And that way you didn't all have to crowd around the big screen. You notice the oddity here. So why did you need a big screen? Well, it turns out that the big screen was a help because they still look at their screen and then say, over there, you forgot X or Y or Z. So it still seemed to help. We liked this a lot. And a lot of people said, well, is this because you were doing distributed decision making? Will it happen over thousands of miles and stuff like that? But that wasn't really our goal. Our goal was kind of co-located distribution, if that makes sense to you at all. But the funny thing is, in this world where we all carry smartphones in our pocket that are capable of interacting with these things, it seems totally foolish to ignore their capabilities, even when you're in the same room. I'll look around here now. See, people are using them right now as I talk, so you might as well harness that for good. So that's their tech. I'm less enamored both of D3 and Meteor right now, and I can talk about that later with people if they're interested in. And we also had weird ideas. And looking at some of the posters out there, I see other people having weird ideas. We like to be able to update the models on the fly. So we did a lot of data flow visual programming. We used this tool called Node-RED by a fellow O'Leary from IBM Research Labs in the UK. And a cool reactive infrastructure called Bacon.js by a Finnish guy. And we also played around with various data sources here. We love MIDI devices like these reactive faders here for setting different things. Faders are particularly nice because they model Inselberg's parallel coordinates because they look like parallel coordinates, so you can drag the sliders and set them. And when other people change them on their device with motorized faders, the faders will go up and down, which just makes such a cool sound when it happens. And you can feel like you're a DJ instead of an intelligent sound, which is obviously way cooler. And we also like mid-air gestures, so we play with connects and leap motion sensors. And this is a system that my student made for people to be able to point in the air and move the data. It was kind of cool because to grab the data, you have to close your fingers, and then you can move it up and down. And when you separate it, it lets go of the data in the middle of the air. All of this came to nothing, but it was really cool. What we should have been working on are two of the most, I don't want to say boring. They seem initially mundane, but they're critical. One is interaction with spreadsheets. When people go away, they want to be able to access the things on a spreadsheet. Why? Because they love Microsoft Office and spreadsheets. And if you can't interact with the spreadsheet sort of thing, if you require them to only use your tool, we're obviously understanding that that's a big lose. The thing that I feel the worst about is what we call the document tab. Like all intelligence analysts, the people in this area work in a world of documentary evidence. They really, really needed some kind of handle on this documentary evidence. And we think more needs to be done for this. Most of the work in this area is done by abstracting away the evidence. And I realize there's a need to abstract away so you have something less big than the evidence. What we saw was the need to still be able to go back to the actual evidence, to reassess it and to check some things out. Because the abstraction, of course, is reduction, and it will often miss things that you need to go back and check when you're getting closer to. We thought that this said it was conclusive. Was it really? What were the exact words? Did it enable the vote? If you're playing Popper's game of falsifiability, you often find yourself needing to go back and check those things. And if you can't, then you buy into the world of bias again, because the easy thing is to ignore it and say, oh, we did that before, and that can hurt. I wish we'd done more on that. What instead we did was another project. And this is our fourth study. I'm so glad that other people have presented Perolean cards sense-making diagram. And I really like, Alex, your comment about in the loop or on the loop and stuff like that. You know, it's like one of those terrible motorway sort of things. We're in loops within loops within loops. All of life is loops. But there's a big implication about these loops. And this has to do with the problem of satisficing. When you loop, it means that you will often get a possible answer without knowing if it's the best answer. And it then becomes possible that you will say, it's good enough, I'll stop here. Particularly, this is influenced when you're manipulating a whole bunch of different dimensions. What can happen is if you decide to go on, then you'll lose what your earlier constellation of settings was. So we would see people coming up with a possible bunch of things and saying, that's good enough, satisfies it, that's bad. Or exploring more and then saying, oh, that earlier one was probably better. Was it? Let's go back and look. What were those settings again? Oh, I forget. Why didn't you write them down? Because clearly, when you're working with advanced computer systems, it's important for the human to write down everything that the computer does. Drives me nuts. So what we decided was, we needed something like undo support. Undo the back browser, something like we have in SVN or Git. Fellow that I met in the live coding world here in the UK, so the great thing about Git was it allowed you to program without fear, because you could always go back to the earlier version. And I loved that idea, and I said, we should build that. I went back and read all of the original literature on the undo button and on source code control and version control. It is astonishing how much of that early work drives designs which restrict the amount of memory you can use or the amount of disk space, because we've hardly got any memory, and disk space is so expensive. But we live in a very different world now. We have essentially unlimited amounts of both. So we thought, why don't we just have unlimited undo? So that's what we built. This is our system called the Remembrall. This is the work of my student Peter Simony. And it works with web applications. So any state of the web application is recorded in this tree. It will remember something if it's in a significant state. You can label the state before and after. And any one of these states you can go back to just by clicking on it. You can get rid of states if you decided that they're no longer important, which hides them. And therefore, after doing a broad assessment, you can go back and really compare the ones that you thought were good. We also have a pretty interesting implementation of this, which uses the new release of JavaScript, so-called proxy objects, which takes all of the objects in the model, puts wrappers around them to do automatic capture of the state in a very nice way. It's not absolutely perfect, much to our chagrin. One of the things it's not perfect for is D3 visualizations, which conceal part of their internal state. But we came up with a workaround for that, which I think is probably the best we can do. And we love this, and we now want it all the time. I want it in PowerPoint. I want it in Excel. I want it in Word. If ever I had something on an application on my screen, I want to be able to go back to the way it was. Honestly, we have this with SVN and Git in the world of software. It astonishes me. In Microsoft Word and Excel, people are still saving out files which say version A 2-March 16th, number 3, and they have a directory full of these sort of things. Honestly, we can do way better than that. We think maybe this is a start. Another thing we found, this is our fifth study, is that when people collaborate around a touchscreen, they point and gesture and draw an awful lot. And I think we do this a lot. I'm certain you've all seen this. Around Hawkins and the Cocker, people will say, well, with our visualization, when the line goes up, we won't. They're looking at a blank wall, but they are still drawing it. how do you remember what's on the blank wall? And people will take photos with their camera, or they'll draw little pictures, and those pictures are important. And so we thought, well, why can't we just draw on the screen? Why can't we have just a layer on top so that we can draw there as we're gesturing and capture that? So we decided to build that, and we did. So we have this thing called strata, which acts as an invisible layer on front of an application. You can toggle with the toolbar. You can do freehand drawing on it. Well, it's like any sort of drawing program on this, which means that you can treat it as a whiteboard on top. The thing that particularly excites me is this thing that we call smart annotation. The thing is, most of the time when we're gesturing in front of an app, the app really knows what's there because of the DOM and because of the style sheet. So when I point this block around here, and I draw a circle on it, really I don't have to draw the circle because the app knows that I am pointing at a block of text, which then it can highlight. And there's a lot of things that can be done in that way, which makes it easier to annotate, to communicate around it. You can also block off large parts. You can say, let's ignore this and focus on that. A lot of that can be understood by the knowledge of the internal structure. So we quite like this. This is my student Moran's work. And lastly, my student Ravina, psychology graduate, pointed out that a lot of the things that we do in touching and gesturing around big screens have a lot of commonality. So she did a study where she recruited pairs of people unknown to each other and got them to work out problems around a parallel coordinates display. This one was a display of crime statistics. And she videoed them all and then did excruciating video analysis of all of the gestures to isolate the gesture from its intent and charted them all to see how many gestures aligned up with an intent. And the answer was a whole bunch of them do. And the thing which you think is very nice about this is that once the app knows what's going on underneath, and once you know that in all likelihood certain screen gestures mean certain sort of things, then the app can help. So for instance, one of the things that people do is they trace a line. Now they're not doing this to talk to the app. They're doing it to talk to their colleague. But if the system sees you tracing a line, it can highlight that line and help it. If you see it, if you see the person putting off a box or kind of erasing other things, the system can basically fade out those other things to focus in on some things. All of these things would support the user's intent with the gestures they already use by the knowledge of what the users are likely doing and the model that they're both looking at. So I think that's pretty cool. So that's the last of my 6 studies. Here's my so what slide. Analysts need support for collaboration. Oh, I didn't mention this when I reported on this. Alternating. One of the reasons they don't collaborate in those later stages, because they strongly believe that they need time alone to focus. You know what? I think they do. However, it doesn't mean that they have to do that all of the time. So the model from our studies that works best is this alternating pattern, where they work alone and then they come back. This is a pattern we've seen a lot in software development, and we think that would work here. But where they don't collaborate very much is in that sense-making phase, and we think like big screen tools like ACH Walkthrough can help. There is this issue of epistemic interaction versus cognitive bias. I've increasingly come to believe that the other benefit is maybe related to the idea that was talked about by Kai-Shu yesterday, that I guess people are calling provenance. I'm used to the term provenance from the antiques world, where provenance means exactly where, a piece of evidence about where something came from. I don't want that so much as I want, from the software development world, I view it a little bit as like test coverage. I want to know all of the things that have been thought about. And the reason that I like systems like this is that it can provide you some sort of documentary evidence of what you did do and what you didn't do. So that's very similar ideas that we've talked about here. And the reason that I think that this is so great is that that will always be a win. And it's especially always a win where there is any form of serious compliance quality analysis done in a system. To be able to say, I can show you what I did, because that's automatically recorded, I think has a big advantage. Interaction history, we think, does a good job for addressing status spicing. The undo button does. The browser back button does. SVN does. We should have that in interactive applications. We think annotation supports collaboration because people will always annotate, and we think gestures can power annotation because there's such commonality in the results. So with that, I'm almost done. I will present one little thing. This is a plug. So a couple of years ago, with some friends at North Carolina State University, we started a workshop on security information workers. Information is the word that we chose not to say intelligence, which is too scary. And we have a workshop at the Usable Security Privacy Conference in June. Papers for this workshop are due about 6 weeks from now, and we'd love participation from this community. So with that, I'm done. Thank you so much.
Thank you, Robert, very much. I'm going to grab the microphone so I can give it to any question askers. That was a very interesting talk, and I hope we have the opportunity to have many conversations about that work. I have a question myself, actually, which I'd like to ask, and it's about the use of analysis of competing hypotheses by the analysts, and I guess I kind of naturally assumed that, given Hoyer's interest in analysts using ACH as a way of combating confirmation bias, they might see it as a bit of a chore, and they might be reluctant to use it in real situations, because it kind of gets in the way, because it slows you down and I'm coming out of my mouth, because it slows you down and that sort of thing. We've been doing some work with police analysts where we've been looking at the way they do reasoning with evidence, and something that we've noticed they don't do is externalize their arguments. So I'm thinking of ACH as a form of argument map, as being equivalent to an argument map. But they don't externalize their arguments, but they have a strong sense of the narrative or the hypothesis, but it's in the head. And so we're looking at that in a sort of distributed cognition kind of way. It's a complete system. But I just wondered, to what extent do you think the use of ACH in this situation was sort of voluntary on the part of the analysts, and to what extent do you think it was a function of the fact that they were collaborating with each other, they needed to expose their thinking, inner thinking?
So, we're very definitely thinking on a similar wavelength here. When we saw it being used in that first study, it wasn't collaboratively. They were doing it by themselves. And to be quite honest, I a little bit got the idea that they were doing it to look good because they knew it was a study, so they were using this tool. I certainly believe that externalizing their argument, like as you say, the argument maps, which, the lawyers have a tradition of studying those decades old, still not used very much. We very much believe in externalization because this goes back to Vygotsky and it fosters the network and all kinds of stuff like that. Here's what I think is going on with ACH. We ran some studies, which for various reasons I can't directly report on, but I can tell you our main findings of the studies. Thing one was, people were obsessed by knowing the details of the mathematical modeling that was going on underneath. Kind of surprisingly. I don't know whether it was just a feature of the people that we were studying, but in many ways, I don't actually regard the mathematical model of Hoyer's as all that important. I'm willing to tweak that. Here's the thing I'm much more suspicious is the answer to my question. It's a straight usability problem. It's just like the kind of program that we wrote back in the 1980s that everybody else in the world who wasn't a computer programmer hated because it was just hard to use. I think that's the number one problem with ACH. People use formalisms like this all the time. Look at the little kind of Foursquare thing that people trying to sell you a card to do. The little triangle things about the food pyramid or stuff like that. They do this all the time. We, that is to say the interaction designers and the computer scientists, just have to do a better job on simplifying ACH. I believe that's the number one thing. And if we could cure that, I wouldn't be surprised if it becomes like number one police tool. I don't want to give up police. Number one analysis tool everywhere. If it's just so simple, they'll use it because it helps them. That's what I'd like to see.
Right, so it's about the overhead for the user, and if we can reduce the overhead, it will slip into the processes because they're pragmatic people.
That would be my strategy. And the other thing, my brother recently bought a house, and I was there for the house inspection, and I was really keen to see the house inspector's report that they give you. I shouldn't have been so keen, because the whole report was just automatically generated by him taking photos and clicking checkboxes on his smartphone that then generated this report. Here's the other reason why I think these people would like it, is it would help them do their documentation, which they despise so much.
Right.
And then they might actually feel better. Other comments or questions? I welcome comments as well as questions. Tell me if something's been already done or you think it's stupid.
I'm Jim from West Midlands Police, and I've been an analyst since 2000. Now I'm a team analyst. I've been coaching into these competitors. And we come in the space to actually do it. We don't want to stop using it now, which is it's sometimes frustrating because they want to take more time. But one of the pieces of work we've done recently is about knife fight. And the question that was asked by the Chief Constable was, why are children carrying more knives? And the analysts, being such a great analyst, started off by saying that's not the question. The question should be, are children carrying more knives? And so we started to think about the competing hypotheses of these questions. And we found that everybody is carrying more knives, and the number of knives carried by children is just in line with everybody else. It's not special to children. We've now discovered that because we don't know the answer to the hypotheses, we now have to go and do research in the community by asking children why, are they carrying knives? Why are they carrying knives? What is it that we need to do to help them stop carrying knives? So it's taken us down a completely different route because we do this hypothesis testing. Like I said, we can't stop people from using it now. It's really good, but there are other techniques as well, and we don't want them to forget about them. Just because the hypothesis work, which I think is a fantastic thing, but if you can help us to do it quicker or better, that would be useful. But all we have at the moment is Excel, which is why we love it so much.
Yeah, and I've seen that Excel thing so many times, and at first I just couldn't believe it until, we're academics. We're supposed to be good at this, right? Especially those of us who are long in the tooth and have seen a million things. But when you find yourself saying, these stupid people, why do they keep using these tools? Why can't? Until you realize, oh my gosh, maybe I should be trying to learn something from that rather than cursing at them. The other thing about what you said that I really like is this idea about realizing that you need more. Because when in this kind of model, you find yourself ranking something as highly relevant, but you're not really certain that it's true, I really love that basically means go and find out. And that sounds exactly what you guys did, which I think is wonderful, and which I think our local police where I live could learn a lot from.
That was one of the whiteboards that are set in there. My boss's office is not wallpaper, it's whiteboard.
Yep. Yeah, we have lots of whiteboards and we have lots of big screens. In our world, the thing that's really important is throw your laptop screen on a big screen to collaborate around with as little fuss as humanly possible. Because, even if you've got the most valuable thing on your laptop, nobody wants to say, oh, what's that? What's that? Can you turn that around? Because it's embarrassing and it's rude and people then won't do it, and not doing it is bad. So yeah, whiteboards, big screens, I love them.
Have you got Excel on your whiteboard? Smartboards. That's the next step. That's progress. Do we have another question? We have one here.
You're not talking about Pythons.
I
fancy cash.
I'm going to ask about Vygotsky
Oh yes.
and scaffolding.
Yes.
When you look at reflection, so when people are in front of your big screens and they're talking to each other,
Yep.
do you see evidence of a scaffolded argument where they take that information, they add something and they want to amend it, and is one of them the sort of the expert coaching the other person? When you talked about role playing, you saw it as role playing as confrontational, but I also wondered whether there was a scaffolding element going on where an artifact being presented to somebody, representation, led to a new interpretation, a new representation, and then the editing of the material.
So we do see that a bit with the facilitator role. You know, for instance, in the cognitive walkthrough, followed Clayton and Lewis's work, right? We often do that in a facilitated manner. But, you know, we also do this in brainstorming. You know, the rule about brainstorming is you don't shut down ideas because you want to encourage flow. Unless everybody really knows that, you need a facilitator to make certain that can happen. The role in this kind of work of a facilitator, following the scaffolding a la Bruner interpreting Vygotsky, right, is the best thing is that you can say, don't worry about that right now, so that we can focus on this, right? This is what Vygotsky would do in the zone of proximal development, right? He would say, let me handle this, so you focus on this, so you're operating in the zone where you can. We think that that probably requires experience and facilitation. That's my line on that. I'm not certain that we can build that into a system. I think that's a skill I want to keep doing. I might be wrong.
But is that one of the reasons why the analysts don't like collaborating? Because they can scaffold each other's development.
Here's the thing about them not liking collaboration. They think it's bad. It's not just that they don't like it. It's that they live in a world which is, without wanting to say who this was, and frankly it could be industry or it's government, they live in a world which is hugely security, need-to-know conscious. They are not used to the idea of sharing ideas. They are especially not used to the idea of sharing half-baked ideas. They also believe very much in themselves. They believe themselves as kind of solitary, deep thinker kind of people. And I don't think they've been introduced to any techniques that can do anything different from that without destroying that whole ethos, which is why I like this kind of alternating kind of thing. I think too many of them regard collaboration as something that they're being asked to be or might be asked to do all the time, every day. And they would hate that, and I think they're right. But I think there's a middle ground that could be introduced through some kinds of formalisms to which I think they would be very receptive. The problem is, it can't be embedded too strongly. And I'll tell you my favorite story about this. So I was at a software engineering conference a number of years ago in the United States, and it was one with a sit-down dinner at the end, which we might have tonight. And so I randomly sat down at this table with other people in software engineering. And there was a woman sitting next to me and, you know, trying to improve my relatively hopeless social skills. I commented on how beautiful the suit she was wearing was. And she said to me, oh, thank you so much. I bought it for my code walkthrough. Your code walkthrough? So she works for a very large software company, and code walkthroughs there, which I was familiar with the introduction of, to help collaboration and reflection in their organization had become a make or break thing for your annual review. It became a thing that you bought a new suit for. Whenever your collaborative techniques become enough to make you go out and buy special clothing, then you know that they're going to fail in their original purpose.
Okay, well, Robert, thank you for that. Many more conversations to be had there, I'm sure. But let me just give you, perhaps we can have a